Good day to all of you. Today we shall solve question number 5a. What do you mean by an addressing mode? Explain any 5 addressing modes. It is asked for 10 marks. The solution is as follows. First we shall define what is addressing mode. The different ways in which the location of an operand is specified in an instruction are referred to as addressing modes. I repeat, the different ways in which the location of an operand is specified in an instruction are referred to as addressing modes. That is, processor is given an instruction for any task, say either to do arithmetic or logical operation, that is specified in the instruction given to processor. So in the same instruction, on which operands or how to fetch the operands or where are the operands, so address of the operand is also specified. The way in which the address of operand is specified in the instruction, that is called as addressing mode. Different addressing modes. The first one, immediate addressing mode. For that, let us take an example. Move #5, R1. Move is the instruction to copy the content. This is source and this is destination. The source is #5 means hash indicates the number. So that is 5. That 5 is copied into register R1. So the data is immediately available in the instruction only, hence it is called as immediate addressing mode. Here the data is number 5. It is immediately available in the instruction only. Second one, register addressing mode. Example, move R1, R2. That is, this is source and this is destination. The content of R1 is copied into R2. So operand address is register itself. Hence this is called as register addressing mode. Here the data is in register R1 only. That is this. It is copied into register R2. This is source and destination. From register R1 to R2 it is copied. This kind of addressing mode it is called as register addressing mode. So next, third one, absolute or direct addressing mode. Example, move LOC, R1. Here source is LOC. This is the name of memory location. So the memory location whose name is LOC, the content of that is copied into R1. So here the operand address, that is memory location, by its name it is directly specified. Hence it is called as absolute or direct addressing mode. Here the data or operand is in memory location called LOC, that is copied into register R1. This is source and this is destination. From memory location called LOC, the content is copied into R1. The operand is in memory location called LOC. Then fourth addressing mode is indirect addressing mode. Example, move in bracket LOC, R1. Here the source LOC bracket is given, that is memory location by name LOC doesn't contain operand. It contains address of the operand. So operand is in another memory location. It has got some address and that address is stored in LOC memory location. This bracket indicates this LOC pointed memory location has operand and that is copied to R1. Here the operand address is in memory location LOC, not the operand. So LOC pointed memory location has the data or operand that is copied to register R1. So another example here is move within bracket R2, R1. Here R2 has some content that is not the data or operand. It is the address of memory location where operand is present. Here address of memory location which has the data that was stored in LOC memory location. This bracket indicates that memory pointed another memory location. Here register pointed memory location means the memory location where operand is present, that address is stored in register here. So this bracket indicates this register pointed memory location, that content is that memory location content is copied to R1. Here R2 has address of operand in memory. So R2 pointed memory location content is copied to register R1. So if you compare this absolute or direct addressing mode and this indirect addressing mode, move LOC, R1. So in LOC memory location 1000 is there, that only is the operand and that is copied to R1. Okay. Here move bracket LOC means if LOC is 1000, 1000 is not the operand. So 1000 is the address of another memory location. So this bracket indicates LOC is not storing the operand 1000. It is the address of memory location 1000. So in that 1000th memory location, what is stored? Suppose whatever data 1122, whatever is stored, that is copied to R1 here. Move R2, R1 means if R2 has 1000, 1000 is copied to R1. Move bracket R2, R1. If R2 is 1000 means, so R2 is having 1000, bracket means in 1000 memory location whatever data is there, that is copied to R1. So that is the difference between direct and indirect. Direct means it gives the operand. Indirect means it gives the address of the operand. Okay. So the next one, fifth one, index addressing mode. Example 10 in bracket R1. So how this is the syntax of indexed addressing mode. How this is used in an instruction? Move 10 in bracket R1 bracket complete R2. If R1 is 1000, so 1000 plus 10 is done. So 1010 is the address of memory location. In 1010 memory location, what is stored? That is copied into R2. So here R1 plus 10 is done. That gives the address of data in memory. That memory location content is copied to register R2. Okay. So next, base with index. So example, move in bracket R1, R2 bracket complete, R3. This is the example instruction. If R1 is 1000, R2 is 2000, bracket means the memory location pointed by this, that is 1000 plus 2000, that is 3000. So in 3000 memory location, whatever is there, that is copied to R3. So this is base with index. Here R1 plus R2 gives the address of operand in memory. That memory content is copied to register R3. Next, seventh one, base with index and offset. Example, move 10 in bracket R1, R2 bracket complete, R3. Here always bracket means that gives the address. If R1 is 1000, R2 is 2000, 1000 plus 2000, that is 3000, plus this index. So 3010. So the memory location whose address is 3010, from that memory location whatever is there, that is copied to R3. Here 10 plus R1 plus R2 gives the address of operand, and that memory content is copied to register R3. Next, eighth one, relative addressing mode. Example, move 10 in bracket PC, R1. PC means program counter. It always stores the address of next instruction. So if it is storing 5000, so 5000 plus 10 is done. So 5010, from that memory location, whatever content is there in that memory location, that is copied into R1. Here 10 plus program counter content gives the address of operand. From that memory location, data is copied to register R1. So the last two addressing modes, auto increment, that is the ninth one. Example, move in bracket R1 bracket complete plus, R2. So if R1 is 1000, So from 1000 memory location, from there the content is copied to R2, then 1000 is incremented by one word. If word length is 4 bytes, so 1000 will be made 1004. That is the next memory location. This is what is auto increment. Automatically after copying, the address is incremented by one word address. That is what is auto increment. Here R1 pointed memory location, content is copied to register R2 and R1 content is incremented by one word size. Means it is made to point to next word. Then 10th one, last one, auto decrement. Example, move, this is decrement sign, minus in bracket R1 comma R2. So if R1 is 1000, first it is decremented by one word address. So if one word size is 4 bytes, 1000 is made 996. So from 996 memory location, whatever content is there in that memory location, that is copied to R2. Here first R1 content is decremented, that is an address. After decrementing, pointed memory content is copied to register R2. So R1 is the pointer, it is having a memory address. If it is 1000, first it is decremented by one word size. So if word size is 4 bytes, then 1000 is made 996, and that 996th memory location, whatever is there in that memory location, that is copied to R2. And that completes the discussion of 10 addressing modes. So that here only 5 addressing modes are asked, but these are the 10 possible addressing modes. One can use this to write any file. Okay, I hope you understood. Next we shall discuss on the solution to question number 5b, asked for 5 marks. Describe the functionality of the following. The first one, MAR, this is memory address register. PC, program counter. Next one is IR, instruction register. MDR, memory data register. And ALU, arithmetic logic unit. Solution. What is MAR? It is memory address register. Processor has some special registers for some special functionality. So MAR stores the address of memory location. Whenever processor reads or writes from or to a memory location, that is from memory when it reads and to memory when it writes, its address is stored in MAR. Means the processor, whatever we give instructions and data to processor, they will be stored in memory. So whenever processor fetches these from memory, it gives the address in the memory or from which memory location it wants to read or write into. So it reads the data and instructions from memory and it writes the result into memory. So processor will be doing read and write operations with the memory. Then with which memory address or with which memory location it wants to do communication, either read or write, and that address it will specify into its special register called memory address register. Hence MAR, memory address register. Processor stores the address of memory location in MAR. Whenever processor reads or writes from or to a memory location, that memory location address is stored in MAR. Okay. Next, PC, program counter. It is another special register in the processor. So it stores always the address of next instruction. It's a pointer to next instruction. Because processor will be executing our given instructions one by one. At present, whenever processor is executing one instruction, the address of next instruction will be stored in the program counter. Because a program has many instructions. When we give a program for execution to processor. So instruction by instruction in sequential manner it starts executing. So when it is executing one instruction, this program counter, this special register in the processor stores the address of next instruction in the program. Okay. Next, IR, instruction register. So when an instruction is fetched from memory, it is loaded into this register of processor for decoding. So we keep our program in the memory. Program means set of instructions. So one by one processor will be fetching for execution. Whenever processor fetches an instruction from memory, it keeps that instruction in instruction register of the processor for decoding. Means in the instruction what is stored, which operation to be done and where are the operands, that has to be assessed. So that is called as decoding. So dividing the instruction or analyzing the instruction, what operation has to be done and where are the operands. So for this decoding process, whatever instruction is fetched from memory, the processor will keep in instruction register of the processor. That is another special register in the processor. Next, MDR, memory data register. Whenever processor fetches data from memory, it is first loaded into MDR of processor. Processor has another special register. When it fetches instruction from memory, that is loaded into instruction register of the processor. When processor fetches data from memory, that is loaded into MDR, that is memory data register, another special register. So whenever processor fetches data from memory, it is first loaded into MDR of processor. Then from there it is taken to ALU, arithmetic logic unit for processing. The last one in this ALU, arithmetic logic unit. It is the main part of processor. So processor has two parts, ALU and CU, arithmetic logic unit and control unit. So this ALU performs arithmetic and logical operation which are specified in the instruction on specified data. So in the instruction, what operation is it, arithmetic or logical operation, that is specified, and on which operands also, that will be specified in the instruction. Okay, this ALU performs the actual arithmetic and logical operation that is specified in the instruction and on specified data. So that completes the solution of question number 5B, which is asked for 5 marks. I hope you understood. So next we shall discuss on the question 5C and its solution. Explain basic performance equation and spec rating. This is asked for 5 marks. The solution is as follows. Performance of a computer means the speed with which it can execute a program, the time it takes to execute a program. Means always the performance of a computer means how fast it can execute a program. So basic performance equation is as follows. T equal to N into S upon R, where R is the clock rate, that is number of cycles per second. Means to different parts of the computer clock pulses are given and events are initiated by the edges of the clock, either for positive edge or negative edge. Okay, so in an execution of an instruction, the steps involved are such that each step will be completed within one clock cycle of time. If clock cycle is 1 megahertz, time period is 1 microsecond. So 1 clock cycle of time means 1 microsecond. So in execution of any instruction, whatever steps are there, they are designed such that every step is completed in 1 clock cycle of time. Say in the example 1 microsecond of time if clock's frequency is 1 megahertz. That is what is R, clock rate. T is equal to program execution time. So this performance equation gives the time taken for execution of a program. That is basic performance equation. It is dependent on clock rate. It is inversely proportional to clock rate. If clock frequency is higher, the time taken is smaller. Hence, to improve the performance, to reduce the time taken for execution, that is to increase the speed of a computer, this clock rate should be higher and higher. That is first point. So the next one, if you take, that is n, number of machine language instructions. Okay, we write instructions in high level language, that is a program that we give to the computer. Then each instruction, whatever we write, internally how many machine language instructions? S is average number of basic steps needed to execute one machine instruction, where each basic step is completed in one clock cycle. Here n is the number of machine language instructions. S is the average number of steps needed to execute one machine language instruction. So many instructions we write. One instruction may have many number of basic steps to be executed. Suppose if you write one complex instruction, internally the number of basic steps to be executed are more. But number of instruction in the program is only one. Program is small. But you may write the program with several simple instructions. So number of instructions is more here. Because instructions are simple, the number of basic steps for each instruction is less. So these are inversely proportional. If one increases, another reduces. If this is reduced, this increases. But when we see to this equation, T equal to N into S. So T is directly proportional to N and S. But these two are not independent. They are dependent on each other. That is why to reduce time, we'll have to reduce the number of instructions in the program. But if you want to do the task with less number of instruction, means more complex instruction will have to write. But in one instruction, the number of basic steps involved will be more. Hence, judicially we'll have to think what is the best combination of N and S value as to get the optimized value of execution time. That is what is basic performance equation. T equal to N into S upon R, where R is the clock rate, T is the program execution time, N is the number of machine language instructions, S is average number of basic steps needed to execute one machine instruction, where each basic step is completed in one clock cycle. To achieve high performance, the execution time T must be low. To reduce time T, R must be very high. N and S must be very low. But they are not independent. They are dependent on each other. But the selection of values of N, S and R should be such that in overall execution time T is reduced and hence the computer is faster. That is what is basic performance equation and discussion on the parameters involved. Okay. So the next part of the question, that is spec rating. In the same question, the second term given is explain spec rating. So what is spec rating? The long form of spec is System Performance Evaluation Corporation. Spec means System Performance Evaluation Corporation. It is a non-profit organization. It always publishes some standard programs or say benchmark programs which can be used to test the computer for its performance, because any program we cannot use and test the computer because the program we use may be very simple, of only one kind. It may not be able to check the computer properly. So the standard programs or benchmark programs which are given by this corporation, that is spec, they are used to test the performance of a computer. So spec rating is the ratio of running time on the reference computer. So this is the standard computer. This benchmark program is run on the standard computer. What is the time taken there? Running time on the reference computer divided by running time on the computer under test. So the same benchmark program is run on the computer under test. Both are compared. The ratio is taken here. That ratio is called as spec rating. Spec rating is the ratio of running time on the reference computer to the running time on the computer under test. This ratio if 50, that indicates that computer under test is 50 times faster than the reference computer. If this ratio is 50, this is 50, this is 1, means ratio is 50, means here this is taking 50 times time more, means this computer under test is 50 times faster than reference computer. Okay. See, overall spec rating is equal to, this is product from I equal to 1 to n, spec of I to the power 1 by n. So spec rating for program 1, then for program 2, then for program 3, like that for all the n programs in the test set. That is done, and all are multiplied, and what value we get to the power 1 by n is calculated. So what is the meaning? If there are 10 programs in the benchmark program set, spec 1 means first program is taken, it is run on reference computer, then on the computer under test, that ratio is taken, that is spec 1, that value is noted. Then the second program is taken, for that program is run on reference computer and what time it takes, and then it is run on the computer under test and what time it takes, the ratio of the two gives second value. Like this for all the 10 programs, one by one 10 values are calculated and those 10 values are noted and all the 10 values are multiplied, that is product, to the power 1 by n, that is 1 by 10 here, and what value we get, that is called as overall spec rating, where n is the number of programs in the test set. That is, the spec rating is calculated for different programs in the test set. Each values of spec are multiplied. For the whole product, 1 by nth power is calculated, where n is the number of programs in the test set. These programs are called as benchmark programs. Here what is to be noted, something to the power 1 by n means nth root of the value obtained here has to be calculated. This is all about spec rating and overall spec rating. That is the second term given in the question, that is for question number 5C. So what was question number 5C? Explain basic performance equation and spec rating. So performance equation we had taken T equal to ns upon R. What is the spec rating we have taken? That is the ratio of running time on the reference computer divided by running time on the computer under test. Overall spec rating, that is product from I equal to 1 to n. So spec of I, whatever value obtained, that is product, whole product to the power 1 by n. So that completes the solution of question number 5C. So that completes the solution of question number 5. First A for 10 marks, then question number 5B for 5 marks and question number 5C for 5 marks. That completes the discussion of the solution of question number 5ABC, asked for totally 20 marks. I hope you understood. Thank you.